Have you ever just stopped and wondered, how does your brain do it? How do you manage to stay on track, focus on one single thing when a million others are vying for your attention, and stop yourself from saying the very first thing that pops into your head? Well, it turns out there's this incredibly powerful system at work, kind of like a control center right in your own brain. So let's dive in and demystify the amazing world of your executive functions.
All right, let's kick things off with a little test. You see the word on the screen. Your job is super simple. Just say the color of the ink. Do not read the word itself. You ready? Kind of tricky, isn't it? Did you feel that? That little split second of hesitation? That mental tug of war where one part of your brain is screaming blue, but you have to force yourself to say red. Yeah, that little internal battle is exactly where our story begins. So what in the world is happening inside your head during that conflict?
The hero of our story, the thing that steps in to solve that little puzzle, is what scientists call cognitive control, or you can think of it as your executive functions. Basically, it's this whole family of top-down mental processes. These are the skills you use anytime you need to really concentrate, pay attention, and, this is the key part, override your automatic gut reactions to get something done. Like forcing yourself to say red when every instinct is telling you to read the word blue.
So why is there even a conflict to begin with? Well, it's because our brains are wired for efficiency. They absolutely love running on automatic pilot. And for most of us, reading is about as automatic as it gets. It's a superhighway we've been paving in our minds since we were kids. Naming the ink color, that requires you to consciously yank the steering wheel and go off-road, and that takes real conscious mental effort. And, as we're going to see, that effort burns a very real resource, energy.
A really great way to picture all this is to think of your executive functions as your brain's very own air traffic control system. It's up there in the tower 24/7, managing the arrivals and departures of all your thoughts, deciding which ideas get priority to land, and, most importantly, preventing catastrophic collisions on your crowded mental runways. It's the only thing keeping your inner world from falling into total chaos.
Okay, so what are the actual tools in this air traffic control tower? What's in the mental toolkit? Well, scientists pretty much agree that this whole complex system is built on a foundation of 3 core executive functions. Let's open up the toolbox and see what's inside.
This right here is basically the blueprint. You can see how it all fits together. Right at the top, we've got those foundational skills, the core tools in our kit. And as you can see, everything else, all those more complicated, higher-level skills we have, are built right on top of them. So let's start with those 3 core tools.
Okay, here are the big 3. First up, you've got inhibition. Think of these as your mental brakes. It's what lets you control your attention and stop yourself from acting on every single impulse. This is the tool that stopped you from blurting out blue a minute ago. Second is working memory. This is like your mental workbench, the space where you hold information and actively mess around with it, like when you're doing math in your head. And third, we have cognitive flexibility, which is like a mental gear shifter. It's what allows you to switch between different tasks or look at a problem from a new angle. Now, this is the really crucial part. These 3 things, inhibition, working memory, and flexibility, they aren't just isolated skills. They are the absolute essential building blocks for pretty much everything we consider to be higher-level intelligence. Things like reasoning, creative problem-solving, and planning for the future. All of it is built directly on this foundation. So we have the tools, but how do they actually work together when things get tough? Well, scientists have been able to map out the exact sequence of events that happens in your brain when you exert control. So let's walk through one of the biggest ideas here, the cascade of control, using our Stroop test as the example. Think of this like a little leadership team inside your prefrontal cortex. First, you've got the manager part of your brain. It sets the rules. It decides what's important right now. Then you have the monitor, which is kind of like quality control. Its job is to spot any conflicts and check how you're doing. And together, they create this seamless step-by-step cascade of control. So here's what just happened in your brain a few moments ago. Step 1. The manager set the goal. Okay, we're naming the ink color. Step 2. The manager then selected the right info, locking onto the color red and actively ignoring the word blue. Step 3. The monitor immediately sounded the alarm. Whoa, we've got a massive conflict here. And finally, step 4. The monitor evaluated the result. Did we say red? Yep, nailed it. And that little feedback loop helps your brain get even better and faster at the task next time. It's just a brilliant dynamic process.
The cascade of control is an awesome model for how it works, but it brings up an even bigger question. How does our brain even decide when to use this effortful system? I mean, why not just stay on automatic pilot all the time? Well, scientists are digging into some really cool theories about how we decide to spend this precious mental energy.
One idea tackles what's known as the inverse problem. Basically, for any goal you have, there are tons of different ways to get there, right? Like if you want to ace a test, you could study for more hours, or you could try to focus more intensely for fewer hours. Both could work. So how does your brain pick a strategy? Well, the theory is that your brain runs this super fast cost-benefit analysis, and that feeling of effort acts as the cost. It instinctively nudges you toward the path of least resistance.
And here's another wild idea, the control-sphere theory. Just imagine your brain has this default idle mode, a really comfy, low-energy state where things are easy. But when you need to tackle something hard, you have to physically push your brain out of that comfort zone and into a high-energy, high-effort state. That's the control-sphere. And according to this theory, that feeling of mental strain you get, that's your brain literally telling you how much extra fuel it's burning to get the job done.
So far, we've mostly talked about executive functions with, cognitive tasks, but their reach goes way, way beyond that. This system doesn't just manage your focus, it's also in charge of regulating your emotions and helping you navigate the massive library of facts and ideas you have stored in your memory.
This brings us to a really key distinction: hot versus cold executive functions. Cold functions are the purely logical ones. Think solving a math problem. Hot functions, on the other hand, they fire up when emotions and motivations get into the mix, like trying to resist a delicious piece of cake or making a really high-stakes decision under pressure. And while they overlap, they actually rely on different brain networks to manage logic versus emotion.
And look, this isn't just some abstract academic concept. This has huge, real-world relevance. Figuring out whether a condition like ADHD, anxiety, or depression involves a breakdown in hot emotional control, cold cognitive control, or maybe both is absolutely critical for developing better, more targeted treatments.
And finally, let's talk about semantic control. Your brain is like this giant internal library of knowledge. The hub and spoke model suggests there's a central hub that connects all the different bits of information. Well, semantic control is the executive skill that acts as the librarian. It navigates this library to pull up the right book, the right meaning, at the right time. For instance, when you hear the word bark, it's semantic control that instantly tells you whether we're talking about a dog or a tree based on the context of the conversation. Pretty cool, huh?
Okay, deep breath. We've covered a ton of ground here, from the basic tools to these complex brain networks. So let's bring it all home. Why does any of this matter so much in our actual everyday lives?
The simple answer is that all of these systems, the core functions, the hot and cold regulation, the control over our knowledge, they don't work in isolation. They all weave together seamlessly to support the variabilities that make us who we are. Our ability to learn new things, to plan for the future, to solve unexpected problems, and to navigate our complex social world.
But if there is one single thing you take away from all of this, let it be this. After decades of research, the conclusion is crystal clear. Your self-control is a limited resource. It's like the battery on your phone. Every time you use it, whether you're resisting a donut, forcing yourself to focus on a boring task, or just trying to stay calm in traffic, you're draining that battery, bit by bit. This phenomenon is called ego depletion, and it means your willpower is not infinite.
And that leaves us with a final and pretty powerful question. Knowing that your ability to focus, to be disciplined, to control yourself, knowing that it's one of your most valuable and most limited resources, well, you have to be intentional about it. Every single day, you're making choices about where you direct that precious energy. So the question is, how will you choose to spend yours?